Welcome to today's webinar using RAG for building document chatbots. In today's webinar, we'll be dive into Retrieval-Augmented Generation and its role in building powerful document chatbots. Yeah, I introduce our expert speaker Alok Yadav, who has extensive experience in AI, machine learning, and chatbot development.
So hello everyone, welcome to our today's workshop. In this workshop, we are going to discuss about RAG, like what is RAG and how do we use it. So we will understand application of RAG as well as we will do some sort of hands-on here, trying to build some solution using RAG as well. So first question is that why do we need RAG? What is the use of that? What is application of that? We need to understand this before trying to look into the other components. So let me quickly share my screen here. Okay, so we are going to understand basics about RAG and then like what are the applications we are solving using RAG. So first of all, what is the problem? Like why do we need RAG? So we have a lot of tools we are using at enterprise level, and we want to, let's say, we want to retrieve some information using RAG. When we are trying to retrieve some of these information, now there are some problems like tools like Elasticsearch or even some sort of database like SQL, NoSQL database. We can retrieve some sort of information. But the problem here is that we have to follow a particular schema and we have to do certain exact matching here to find out. Same thing, like some of the other applications, like when we are working on taxonomy or maybe when we are working on ontology. At that time, when we are trying to use structured data, for example, like when we are talking about medical fields. So when we are talking about medical fields and when we are working on that, so there would be very specific terms which we cannot, solve it. So using a simple query when we are doing, we will not be getting a relevant information. We may be having a document management system like we have a very large document. So a retrieval of getting a proper information may not work here. So what we see here is all the different challenges that we are having with respect to using a simple query or maybe certain information that we want to retrieve. And mostly when we talk about GenAI, so when we are trying to either connect to some sort of database or we are trying to read some unstructured data, the challenge is that we are not getting the relevant information. So that is a problem. And how do we solve that problem? By using a technique called as RAG. So here, if we look at RAG, it's made up of three important terms. One is retrieval, augmented, and the third one is generation. So the first one is retrieval, second one is augmented, and the third one is generation. So what happens here? Like whatever challenges we have seen regarding doing some query, getting some information, or maybe retrieving some information from the RAG, by normal method, sometimes we may not be getting a proper output. And this is where we are using RAG. So what RAG is doing? RAG is combining different techniques. For example, one is retrieval. So we should be able to get a proper information from any document. It could be any format of the document, structured, unstructured, audio, video, it could be anything. So whenever you want to find out something, we can do the retrieval and then using the GenAI capabilities along with that retrieval so that the GenAI models can look into a proper context and they can create a proper output. So one thing based on certain query. So we need to have some input. This input has to be interpreted by the natural language understanding by the LLM model. They will search and they will try to find out a relevant information. For example, let me give you one scenario. Suppose you are trying to query about certain insurance policy or maybe certain HR policy on any organization data or maybe PDF. Let's say I'm asking about the insurance policy offered by Google to its employees. we may not get exact information because no organization will share that information outside. So any LLM that we might be using may not give us a correct output. So how do we solve this problem? We can solve this problem by fetching the data that we want. Okay. So like any organization that is having some local data or maybe some data, so we can use these capabilities and we can send a relevant information that they're asking for. For example, if somebody is asking about a leave policy or maybe an insurance policy, so in the entire organization PDF, the information that is having in a database form in a PDF, page number 50, page number 60, page number 70 have the relevant information. So those page information will be extracted and only this part of information will be sent to the LLM. So here what we understand is that based on the query, like whatever the query has been done, it has to go and it has to search for a relevant information on the basis of the query, and then the query as well as the relevant information, both of them will together go to an LLM model, that is a GenAI model, and that will create the output. So here you can see, this is how it is working. These LLM models, uh, they are using the context. The context is our data that we have given here. So what we are doing, we are using two things. One is that we are trying to retrieve a relevant information. That is one part. Second part, that relevant information that we are extracting, we are sending it to the LLM model or the GenAI model to generate a response here. So I can see there is some query. Exactly. LLMs lack the recent. That is perfectly right. You know, the example is recent.
Hi, Alok.
This
Your voice
mod,
is breaking actually.
you're using the base model like or maybe so yeah. Hello, is
Hello,
it?
Alok. Yes, your voice is breaking a little. We missed you from last 1 minute.
Okay. Just let me know. Is it fine now? I just changed
Yes,
my
yes, yes,
network.
Alok. Yes, we can able to hear you.
This is better. Okay.
Yes.
Okay. Perfect. I'll come back. What I was telling. So fine. So, like we were discussing about the challenges. So sometimes what happened if you look at the previous models, the previous models is the previous models like GPT 3.5 or maybe GPT 4.0, sorry, 4, they have certain cutoffs. So if you want to ask certain question, they may say that, okay, I've been trained only to this state. I may not be able to answer this question. Like this is one of the challenge that we are having. So by using RAG, we can solve these problems. Okay. Now, if you look at like basic models versus RAG, so the traditional LLM models, the model could be like GPT model, GPT 3.5, GPT 4.0, or it could be any model like Llama model, Mistral model, or maybe Gemini model from Google. So they have been trained, like there has been some training done, and so that training is having, as you know, we know it is be having certain timelines which it would be trained. It would be having some cutoff date, and because of that, what happens? It may not be able to answer properly. There might be some sort of inaccuracies. It may not give a proper output. This is what we call it as a hallucination of the model. We are trying to ask something and it is not giving us proper information. So when we are using RAG, what are the advantages that we are having by using RAG? One of the thing is that any external database that we are having when we are using RAG, it may be able to access that data, the relevant section of the data, and give us a proper response. So it will reduce the hallucination. Second thing, we may also have a real-time information. So because we can retrieve the latest data, and the LLMs can go and check that data and give us the relevant information. Along with the query, we can also retrieve the proper information. So we may also have a contextual relevance of the answer that we are having. And because of that, the output will be better. And the most biggest thing is that we don't have to train or fine tune any of the LLM models. Now, one of the things that we do normally when the model is not generating a response, we have two options. Either we go and fine tune those models. Okay, we have to train those models. But remember, this is a very, very costly business. So once we train the model, we have to host the model. So there would be a training cost, which is very quite high, using 800 like GPUs or maybe any other. So the training itself is a huge, it's a costly business. Then this model somewhere we have to store. So we have to pay the inference cost. So apart from doing that, what we can do, we can just use the same foundation model. So we have to only pay the token cost. We don't have to train anything. So because of RAG, we have this advantage. We save a lot of money there and we don't have to train it. We just have to use our data and get the relevant answer. So that's what is the advantage of using RAG. Now, what is a RAG stack? How does it looks like? So you can see here, we may be having a different source of data, like structured data set, some sort of DB we might be having. We might be having some unstructured source of data set, like some MongoDB or maybe DynamoDB, and then semi-structured data, like some web, web pages that we are having, or maybe data coming from some sensors or some other thing using some APIs. So data can be coming from different sources. Initially, we have to do some sort of data processing. Okay. Then after doing the data processing, we have to do some indexing of that data set. So this is very important step. Whatever data we are having, that data we have to pre-process, number one, and we have to do some sort of indexing with that data set. And then we have to store that data. So whenever a user is asking any question or the user is doing any query here, the question goes to the LLM model. The LLM model could be any, like GPT model, Gemini model, Cloud model. It will try to search the database. Okay, this is called as vector database. So we store it somewhere, and one of the place we store it into a database that is called as a vector database. So the question will be asked on the vector database. It will be generating some output. It will get some relevant section here first, some context that will go to the LLM, and the LLM will be generating some output here. So that will be coming as an output to the user. So what are the different stages that we are having in RAG when we are doing RAG? So these are the important stages. The first one is that you have to load your data properly. As we discuss, data, when we are doing that extraction, when we are building that ETL pipeline and all. So data, the first important thing is about loading the data. We have to acquire and we have to prepare data from different sources. It could be a flat file, it could be a text file, it could be a SQL query, NoSQL database, or maybe data coming from APIs in a JSON format. Any format of data, we should be able to load it here. Now, once we get a data, then we have to do indexing. Means that data cannot be fed directly to LLM model. Large language model may not understand that directly. For example, you are having some video. Let's say you have built a driverless car. Tesla has built a driverless car. So it is sending some real videos, for processing. That video model will not understand directly. That video have to be processed. It has to be prepared in such a way that the model understand. And remember, computer always understand everything in a numerical format, in a vector format. So any data, whether it is audio, video, text, it has to be converted into a vector form. And then that data have to be stored. So what we do, we have to do indexing of that data set. So data, we have to prepare in such a format that it is stored in a way we all have these vector embeddings. Vector embedding means we convert the data into a vector form and then we store it as an embeddings. Like we can select certain dimensions of that. For example, normally when we have two dimensions like x and y, or we may have three dimensions x, y, and z. Like that, we can go on like 200, 300 dimensions. So we store data in, so we prepare data in that form, doing a proper indexing. And then once we are doing this indexing, what we have to do? We have to store these data properly. We have to store these data properly. So we cannot store them into normal databases because this is a different format. So for this, we required a vector database here. What do we require? We require a vector database. Now, there are different types of vector database. For example, Pinecone, ChromaDB. So some of them are open source, some of them are paid, which we are using here, storing the relevant uh, information or the data that has been indexed. And after that, we are doing a query. So whatever user is typing, that input also has to be converted into a vector form. So whatever user is asking or whatever query that we are having, that query also have to be converted into a vector form. Then that query, suppose here is some question that here is some question the user is asking. So first of all, that question also have to be converted into a vector form like 1000, something like this. And already we have the data here. All the relevant section of data is already into a vector form. So that will come here, try to find out whether this is matching or this is not matching, this is matching. Whatever the relevant information is there, it will try to find from here. That is what we are doing the query here. And then that will be sent to an LLM model. This LLM model that we see here will be looking into this uh, query as well as what is the context that we have got here, and it will be generating the response. This response that we see, we can evaluate the model. So if you look at RAG, these are the important stages in RAG. One is loading the data set. Second is indexing the data. Third is storing the data into some sort of vector database. Then doing some query. And finally, trying to evaluate the performance of the output that we have got. So these are the major stages in RAG that we are having. Now, we saw about this loading and all, like how data is coming. But how do we do the indexing? Let's try to understand this. So the goal of indexing is that whatever document that we are having, it should be prepared in such a form that our large language model is able to understand. How does the large language model understand? It understands into a vector form. So how do we need a data? We need the data into a vector form, like 100, something like this, into a vector form. And when we convert, like we may be having some text data here, or we may be having some audio, or we may be having some video like this. So these all have to be converted into some sort of vectors. And this process is called as embeddings. What do we call them? We call this process of converting a raw data into a vector form is called as an embeddings. So we may be having word embeddings, audio embeddings, video embeddings, all these things which we will be storing in a vector form in some sort of database. So in text, we have a text as an input, then it goes to the model. This model will do the embedding. It will convert the numerical, like the text data, into a numerical form. And it is not just the form, but it is also having the semantic similarity. What it means is that the words which are very similar, they will be close to each other. What you see here, like for example, we have this BERT model. It is one of the uh, transformer models that we are having. And finally, we need some sort of database to store them, like Waviate or some other database that we are having. So we have to prepare embeddings of a database, some sort of vector database. The second important thing, before preparing the embeddings, entire data cannot be fed into the model. Like you cannot feed entire data. It will be very, very computationally expensive. So what you need to do, you need to break the data. Like if we have this 1000 page document, this entire document we cannot send it once. It will not be able to handle such a volume of data. So what we have to do, we have to break it. One way what we can do, we can break it like page by page. So you can send one page, one page, one page like this. This is a simple way of doing it. In GenAI, what we do, we try to do chunking. Means what? Chunking is nothing but where you're trying to break a large data set or a large document into small pieces. For example, now this is a paragraph that we are having. If you want to do chunking, so we can just take this one line like this, okay, till here. Then this is one chunk, we can prepare it. And then this would be the second chunk. But then we need to connect them. So what we can do, we can keep some sort of overlap. Like this is one overlap between them. So we can start from smaller. This will end after smaller. And then we have an overlap. So this is how we prepare the chunks. Very, very important because we have to break our data. So always remember one thing, whenever we get this raw data, so we have to prepare indexing of that. That data we have to prepare into a vector form. Before doing that, we have to break our data. And the process of doing is using chunking. So we have a chunk here, like chunk 1, chunk 2, chunk 3. These chunks are too small. So like if they are too small, they will be a problem. If they are too large, they will be also a problem. Like it will be a computational expensive. If it is small, it may not be able to capture the relevant meaning. So it has to be optimal. Okay. So that we get a good accuracy or we get a good output. So remember your database, you have to do a chunking. Then we prepare the embeddings. We convert the data into a vector form. It could be a text data into a vector form. It could be audio data into a vector form or a video data. And then what happens? Somebody does a query. That query also will have to be converted into a vector form. So this also vector, this also vector. So what we do a vector search here. Like we find out most similar output, whatever is most similar to this input that we are getting, and that response is sent here. So what we discuss, we try to understand this process here about how the RAG is working. And it all depends upon what use case you're solving. Different model is having different size of chunks that we are doing here. So then, so coming to the size that you've asked, so here you can see normally when we say we will be having the chunk size, for example, 128 to 2048. So when we are breaking these, we have a tokens here. We don't count it as a word, but we count it as a token. So in OpenAI, I can take example of OpenAI. 100 token is equal to 75 word on an average. I'm just giving example here. So 100 token is equal to 75 words. This is what we are having in OpenAI. 100 token is equal to 75 words here. Okay, on an average. So you can see here we have a different chunk size. So this is having like 128 tokens or maybe 2048 tokens. And based on that, if you see, if your token size is increasing here, what will happen? Definitely, you will require more time to process the information. Why? Because you're sending more and more data here, as you all can see. So this is about chunk size and the response time it will take. Then embeddings. We discuss what is embedding. Embedding is a process where we are converting our text data into a high dimension vector, which is capturing the meaning behind every word. We just throw away into a very, very high dimension space, like this example you see here. Okay. So here, what we see is just a 3-dimension, like x-axis, y-axis, and z-axis. So this is just a 3-dimension. Imagine if I have to give example of 200 dimension. It's a huge amount that we might be having. I can give you one example here. If I show you this one, this is a TensorFlow. We have these TensorFlow embeddings. Okay, so if you look at these, you will understand what I'm talking about. Here's an example. So this is 200 dimension that we see, and all what you see here are different words. So you can see different words here. Let's pick up one word here. Okay, like Lincoln. So if I further zoom in, so you will see all the word related with Lincoln that you can see here. Okay, like if I play, you can see all the words related to Lincoln. So all these words are there. If I say Monday, now you can see which are the words close to the Monday. So you can see broadcast, hours, uh, attendance. So all these words close to this. So this is what we're talking about. Now this is example of 200 dimension what you see. Okay. Okay, there's a question. Do you think that indexing is the best word for that? Still should be? Yeah, it should be anything like embedding. I mean, you can change that, but it's just a stage. We can say it as an embedding, vector embedding, whatever you want to say. Indexing is just maybe a label for that, which could be updated there. Okay. So this is how I just showed you that we are converting that into a high dimension space here. Like that, we have seen that. So what is embedding? Embedding is nothing but it's a technique where we are trying to capture the words which are very similar, like where they are having some sort of relationship. And we are trying to project them into an n dimension space. Like the one that we saw was 200 dimension. Like that, we can increase the dimension of that, and it will become the words which are very close, they will come together. The words which are not too close, they will not be there. So embedding is used in all the applications that we are having. All the LLM models, all GenAI models, they use embeddings. So for example, like search engine, we are using it. We are using it in recommendation. We are using it in some sort of virtual assistant. So remember that what embedding does, embedding captures the dense vector representation of the text. We are just looking at text. Same way we can look at audio, same way we can look at video. So that is going to capture a dense representation of that. So it will be having a semantic meaning. It will be having semantic similarity based on the machine learning algorithms that we are having, that you all can see here. Okay. So there are different types of embeddings. Okay. What you see here is just something like we have got word to vec. Now this was a very, very good model proposed in 2013. Like this is again one of the primitive models, which is based on understanding the context of the word. So there were two methods. One is called as skipgram method. One is called as Sibao method. So what happens in this, like you have the surrounding words. You're trying to predict the middle word. Like I have some surrounding words. Okay, here, here. So you're trying to predict the middle word. What will be the middle word here? Or you are having the middle word and you're trying to predict the surrounding word. Like example, I say sky. So here you will try to predict the color of sky and then is blue. Like you will predict the other words. Here you have the words which are in the surrounding, and you will try to predict the central word. So that is what word to vec model did. Same way we were having this model again, like Globe and fastest. So Globe was again, it was trying to capture the relationship of the words. Fastest was very, very good model. So it was looking at not only at word label, but it was breaking the word. Sometimes, if we get a new word, we may not be knowing that. So it breaks down the word and try to see if after breaking the word, it is having some sort of similar words in the dictionary or not. And basis of that, it was trying to predict. So we got this BERT model, which is having its own way of preparing the embeddings. And these all are based on architecture called as transformer architecture, which is based on the research paper published in 2017 called as Attention is All You Need. So this all is based on that research paper. And all this entire journey of this GenAI started after this paper was published. So the foundation is the transformer architecture, which is valid for all the GenAI models that we see today. And in that, we have the attention mechanism. The meaning of attention mechanism is that only focus on the relevant part section that is important. than just looking at a complete data set. Then OpenAI having its own embedding, they call it as an ADA or text embedding that we are having, so which is very high accurate. They have been trained using some sort of deep learning model here. So this was about embeddings. Then I was talking about these basic models, like you can see here. So these words that we see, okay, these words that we see here, like king is closer to the queen, a man is closer to a woman, they will be together like in 3 dimension space, and then you can find out the other words. So this is how, when we prepare these words for embeddings, based on the semantic similarity, they will be together, so we can understand. Now again, this is some sort of advantage, disadvantage of each of the methods. These are the recent one that we are using, like advanced embeddings, which every model is using now. Like RAG is also using the same thing. So it requires an API access. This all is available on their portal. We can use it from them, or we can even go with open source like BERT and all. There are other embeddings which could be used. So one of the place where we can get this embedding open source is Hugging Face. It's a platform. If you go to this platform, Hugging Face, you will be able to find out all the embedding. So you can check all the embedding model here. This is having so many embedding models. Okay. Sorry, it is here. So here we can find out all embedding model, as you can see. We can try which one is doing good. There's also a leaderboard that we can see. So if you want to compare which one is doing good, you can go and check this one. I'll put it in the chat. So here we can see all the embedding model open source. Now, what is their performance, like how they are doing? It is taking some time to load, but I will try to put it in the chat. You all can check it later on. So we get a detail of all the embeddings here. Do other LLMs use OpenAI embedding? No, they cannot use. Like every model is having a different embeddings. They are using a different embeddings. Okay, whatever we are using here in ChatGPT is different. Whatever we might be using for Claude, or whatever we might be using for, like here we have OpenAI. So this OpenAI Studio that you see from Google, whatever embedding that it is using is a different. Whatever embedding that we are using in Claude is also different. It is not the same. Like I'm just opening here Claude. So it is using these models, Claude 3.7. This is from Anthropic. So this is entire Anthropic platform, but the embeddings are going to be different for all the models. They are not the same. So you can think it like that. Embedding is the game. If you are able to do a proper embedding, I think if you're able to get a proper output, half the race is won there. So embedding is a very, very important. That is the game that we are having. So now in RAG, what we are doing in RAG, these embedding layers, they will take the input and they're going to transform that into a very high dimension vectors that we are having. And remember, the words which are similar will be coming together. Okay, there's some question. If anybody is having question, you can ask the question. Need to use the same embedding to the query? Yes, exactly. Because it has to be apple to apple comparison. We cannot have apple to orange. So whatever embedding we are using here, we have to use the same embedding for retrieving also. Like some queries coming, that also have to use the same embedding. Okay, not a different one. So if you look at these embeddings, so these embeddings, they represent the meaning of the words, phrases, or maybe the sentence. And so what are the important things that we are having here? Tokenization. The tokenization is nothing but how do you break your data set into a tokens? And then we have a vector. So we try to map every word with some sort of token. And when we are having a huge data set, then that embedding has to understand the contextual uh, relationship between every word that we are having. So the game is all the embeddings. Now we have pre-trained embedding. So we don't have to do anything. Somebody has already done the job for us. We have to use that. But these embeddings are pre-trained on a lot of these, words. So some of the words like some of the data like Wikipedia, or maybe some online ebooks that we are having, they have been trained on that. So they know the contextual words. So they can be used for semantic similarity, like which documents are similar. If you want to find something, you can use that. They know the context very well. And also they've been trained on different domains like healthcare, real estate, finance. So they know very well. This is what I'm talking about, a semantic similarity. So the words which are very similar, they will come together in the vector space. So in n dimension space, as you can see here, when we are talking about a boy, so the other words similar to this, the sentence will be here when we are talking about a cat. So this will be similar to that. This is how the embeddings are here. How are the embeddings for individual words converted and calculated into the embedding for the chunk? So you take the embedding as a sentence. So there are two ways. Like here, what we are doing, this has been a vector embedding. So when we are preparing this model, the model have been trained to understand this and prepare the embedding. So there have been different techniques that we are doing to understand that. You need to understand the process, how it is done. For example, first you have to do a tokenization. Okay, you have to do a tokenization. For example, you see here 3 bedrooms, we have this text. Okay, we have this text, 3 bedrooms, 2 baths, ocean views, and newly renovated. So suppose this is our text. What we have done, we have divided it into a token. Now this is like one token, this is next token, this is next token, and this is next token. So we were having one sentence. That sentence, what we have done, we have broken that sentence into small chunks or tokens, like this one that you see here. Second one is somewhere here. Third one is down. And then we take this one, and let's say I want to convert this into a 5 dimension. Now, this is X and Y. This is like 2 dimension. Now this becomes a 3 dimension. Like that, we can add 4 and 5 dimension here. So what will happen? Every word will be having 5 dimension. This is, for example, this is for first dimension like X, Y, Z, like this you will have for all of them. So we can write it as 1, 2, 3, 4. So this is like 1, 2, 3, 4, and 5. So 5 dimensions we are having. Like this, every word will be getting in that vector dimension. It will, get there. And then the words which are very similar will be coming together by using this technique that we are having. Token we discuss in OpenAI. Token is like 100 tokens are like 75 words. So you can see here how it is going. Sometimes even these special characters are counted as separate tokens. Okay, here also you can see. Like that it is going on. So it is having its own mechanism of looking into this. So this you can see. This is an input text, what you see here. And first we do tokenization and then we do the embedding of that, which you can see here straightforward. So any data that is coming, we do a tokenization and then we are doing embedding of that. Then what we do after that, after these things are done, we have to store them somewhere. So we cannot store them normally because it is having a high dimension like 200, 300, 400 dimension. So we need a database to store. So you can see here, be it Milvus or Pinecone, there are different types of databases which will store the indexing as per this. After that, what we do a query. So when we do a query, when a user is asking something, first of all, the user input will be converted into a vector form. Text cannot come directly. That vector will come here, and what it will do a semantic similarity. It will do a query transformation. So first you will do a semantic similarity based on the indexing. I will try to do a matching, and then after, let's say I find the top 5 matches, I will do a ranking and the filtering. So based on the relevant ones, I will try to pick up the one which is very similar to each other, as you can see here. And then what we do a ranking. So suppose we found 5 relevant sections, okay? But then which are the important one, which is the top one? So we do some sort of ranking This is based on the model that has been trained. It understands the context. So basis of that, it will do some sort of ranking. Like here you can see sorting that and generate the response. So we are having some other techniques where we can go and we can do some sort of ranking here, some sort of re-rankers we are having. Okay. And then we are having this OpenAI's ADA model that you can see here. So this is example of how we are doing the re-ranking. Is the word that we are having. So what we are doing, okay, basically this what you see, I think here we are having some sort of typo error. Okay, so this is a typo error, but this is ranking. I think I'll correct these, but this is some sort of we re-rank them based on go here re-ranker that is doing a re-ranking here. Same way, we also have OpenAI ADA model. Okay, this is also used for finding out the top search. So this has been trained, one of the fastest OpenAI model, which is doing the same thing here, and it is generating the output based on searching that. So because of that, what happens? The RAG is having a good contextual information. Then we have some other techniques for indexing, like if you don't want to use a vector database, then we have a library from Meta, which is very good library. This is open source. So this is Facebook's AI similarity search, which we use for indexing our database. Okay. And how does it does indexing based on flat indexing or maybe inverted or maybe some sort of hierarchical so all these hashing and all it does basis of these different types of indexing. Okay, there's a question. Tokenization is a type of encoding tool. I don't know that, and then it's encoded again by encoding. Tokenization is like you try to prepare a small chunk of your data. Okay, so basically what we do, we give an ID to that. So whenever any text is coming, you break it down. That is what we are calling it as a chunking, and then we are giving an ID to that. Okay. I'll tell you, this is very simple. If you see whatever data we are having, okay, that data is coming. So first of all, the complete paragraph we cannot take. So we'll break it down, okay, into chunks. The process of breaking down into these chunks is called as small chunks, that we are breaking down. So what we are doing, we are trying to prepare them as a tokens, okay. Ideally, every model will be so don't get confused with the chunking and the tokenizations. Okay, chunking is that how you're breaking your data. Tokenization is a process which the model has been trained. So you don't have to do anything. The model has been trained to look into data. So now when we talk about these different LLM models used in RAG, Gemini, OpenAI, Anthropic, we can go with Llama 3, we can go with Mistral or Gemma. So all are different GenAI models that we are having. Which we are using, okay, and then we are having certain frameworks, certain orchestration framework to link everything together. One of the example is LangChain, which we can use. Other is Llama Index. So these are the two famous orchestration framework that we are using with RAG. So what they do, these layers, they are managing everything, like the complete flow that we are having. These layers, they control the different components. They ensure a seamless workflow for any query that we are having. That is how we are just trying to use it. So you can see here, we have a LangChain framework here. So this is the LangChain between. What it is doing, it is using a tool. So tool will be like different types of tool. For example, we want to extract some data from internet, we can do that. We want to use certain LLM models like using OpenAI or maybe using Gemini model that we are having. Text splitter will be used for splitting the text. Same way, document loader, how do you store your vectors, what prompt you're using. So this is LangChain framework that we use for RAG. This is especially, orchestration that has been that we are using so that we get a proper, output, as well as we try to streamline the entire process that we are having here. So this was about using LangChain framework. Other one we are having is Llama Index. So you can go with either one of them. This also you can see what it is doing. It is handling the data set. So data will be coming here, embeddings are there, LLM model is there. Then we have the vector database, as well as we are having the evaluation, data indexing and retrieval method. Here also we can do large scale, query. We can ask some information. We can retrieve the volume of data. So this is another orchestration framework that is helping us with this. Again, you can compare. Either you can use any one of them. Both of them are does. It emphasizes on modular design. So you can do a prompt management. Okay, we can do the workflow automation. So here it is more about building some sort of complex solution if you want to do so. This is very, very popular. Okay, so but again, that we have to fix. But LangChain is very good if you're trying to develop something, okay, or doing some sort of POC. Llama Index, where you can see, Llama Index focus on indexing and everything. So more if you're building some sort of RAG application, okay, so you can go with Llama Index. So as well as you are doing some sort of retrieval, okay. So this is more robust method.
Hi, Alok, again, your voice
LangChain.
is breaking.
I think some network problem today,
Yeah,
my end.
no worries. It is already like 10 minutes now. We can manage anyhow.
I'll just switch off my video here. Maybe that would be.
Yeah.
Is it coming proper now? Okay.
Yes,
Is
yes.
there
Yeah,
a
you're coming.
somewhere? Is there a tutorial we can walk through the whole process?
From my
Yeah.
perspective, you were coming in clearly. I don't know if other people had a different network issue.
Okay. So here, what we are discussing, like there are two different orchestration frameworks that we are having. We can use either one of them, and so we discuss about both of them, and finally you go and evaluate your model. So just to make it simple, this process that you see, what are the important parts here? I would like to quickly revise this. So just give me 1 second. We will be looking into these. I have a lab also, but again, I wanted to take some questions. So I'll just make it more simple, and we just look into one example just to understand how this might be working. So I can give you all one example how RAG is working. Let's look at that quickly, very quickly here. So let's say you want to build some sort of open source RAG. So here I've just defined everything. For example, using some sort of documents. So here you can see how do we start. So first, for example, start. So here we want to actually do some sort of query on some sort of PDF documents. The entire process, the entire data into small sections or chunks which the model can understand, and some sort of overlap we follow. So we use a function called as recursive character splitter. What it does, it is from LangChain, it is breaking a small piece of information. We are trying to import all these required libraries, as you can see. Then we load the PDF. So here I have loaded all the PDF that you can see. Total there are 5 files that I have loaded. Now what is the next step? So we got our data here. First thing, Second thing, we'll do a data preparation. So these data, there are 5 PDFs that we are having. We want to split them. We want to break them into small chunks. We want to prepare that. And how do we do the chunking? By using something called as a function called as recursive character text splitter from LangChain. So next you can see here, we are doing data preparation. We are going to split the data into small chunks, and we use this recursive text splitter, character splitter from LangChain, and we are splitting our data. So we got 7 split. So you can see all the chunks here. Okay. So this is a chunking of a PDF, a big PDF that we have got. Around 5 PDFs you are having. After doing the chunking, what is the next step? We have to do embedding of our data set. So we have done this chunking. Now we have to use that chunking to create data into a vector form, into a numerical form, okay, into a vector database. So remember, we discussed about files here, which could be used. So first of all, we need one thing. We need a model, embedding model, which can convert these chunk of text into a vector form. So what we are doing, we have all these, as you can see, sentence transformer, mini LM model. This is one. Okay, like that, there are many other models. L12, V2, you can use any one of them. They have been trained on like deep learning models for embedding. And this all is available on the Hugging Face website. You can download. So you can see here from Hugging Face, I was different embedding models and the performance of each of the model, number of parameters. So many are there. We can use any one of them. This is on Hugging Face website, Hugging Face portal that you all see here. Okay, where is tokenization happening? Tokenization will be happening when we are. If you look here, we are doing the embedding using this model. We download this model from Hugging Face. So all this step that you can see, we are downloading the model. And what we are doing here, so we get the embeddings here. Okay. And then after doing embeddings, this is where the entire tokenization process will database. Okay. So for vector database, we are using a FIAS. FIAS is like a local, it creates a vector database, which we have done here. Okay. So this is the entire process. Till now, we just prepared the data set. So now you want to ask some query. Okay. So you have to create a retriever that will. You also need a model. So here what we are doing, I have downloaded a 5.3 model from my 5.3 model from Microsoft. This is a small language model. We can even use any of the large language model also. Okay. So I've just downloaded this model here, 5.3 model. So this is on completely on local. I'm saving it on my local machine, as you can see. So this is around 7.12 GB model. You download this. And then what you're going to do, then you will set the path of your model. This is on my Google Drive. So I set up all the path. And after this, what we'll do, we'll be questioning. So we'll take our input, like whatever input we are having by using LangChain. So you can see we are using LangChain here to create, like to combine the retriever with the document. So we create this retriever chain. And then we are having this prompt here, like, you are so you write your prompt, whatever instruction you want to give here, you create that. For example, here you are an expert in mortgage, and then you answer some question based on the document, and don't give me any information outside that. Only answer what is there in the document, and then we want it like this. Okay, then you create a document chain of this, and you create a retrieval of that. So this is all we are doing. And finally, what we do, we just ask some sort of question here, like, okay, answer about mortgage. So it will only answer from our chat, and then you can create some sort of web application. Right now it is not running, but if I create, so it will look like a chatbot, proper UI that you are having. I'm just giving you the demo of this, how you can build end to end. And if you need some information, I have this notebook, this workflow, I can share with everyone. You all can go through this. So this link I will share. If you're interested in understanding this entire process, how RAG is working, please go and check this one. Now we can take some questions here. We still have some time to.
Struggling to understand the tokenization step uh, and differentiate it from the embedding step.
So basically, see, if you take a simple NLP, what is tokenization? Tokenization is a process of breaking your data into small units or small chunk. So here, when we talk about tokenization, one of the thing is that it's a chunking process that you see here. That is exactly, what we are having here. So that's what we do a token. Token means what? There are two types of tokens. One is a sentence tokenization, one is word tokenization. So basically, either you have a big paragraph, you can go line by line, line by line. That is called as a sentence tokenization. Or you can go word by word, word by word. But the problem here is that if you do word by word, you lose the context of the word, because words coming together will make a sense. So we do a chunking here. What we do, we take few words together and then we take an overlap. So this is the process of tokenization here.
Joseph has raised his hand.
Yeah, I was just wondering what type of scale you've dealt with. Does RAG scale pretty well? And what databases do well at larger scale?
So for enterprise level, we can go with for enterprise. So we all need a proper vector database. That is the game, because if you take a huge amount of data, so it will create a huge embedding. You need to store it somewhere. So Pinecone is like production level you can get, or even Waviate is also offering. So there are many. So yeah, Quadrant is also, there are many. So you can look into that. So once you store it, into a vector database, rest any model, the code that I shared you, it is a production ready code. It could be used anywhere. So you can use the same code. Take any model like Llama model, open source model that you want. Is up to you how you want to take it.
Can it scale like Elasticsearch, or is it still
Yes,
going to be, wow,
it
that's
is
cool.
better than, I would say, better than Elasticsearch. We can do that.
Cool.
So thank you everyone. I've shared a link. Go through that. And if you have any question, query, I'll share you my LinkedIn profile. You all can connect with me if you have like any question or there is some requirement you want to discuss. Anything on agentic AI. I'm building a lot of agentic AI. So if you're interested.
Yes, people who
You
has
can.
interested in agentic AI and any AI courses, like please visit our website, AgileFever.com, and you can also access the LinkedIn page of our look.
So some courses that we are launching. One is agentic AI. It's starting this month. If you're interested in how to build agentic AI solution, AgileFever is launching that course. You can go and look at that. Maybe once this webinar is open, you all will get a link, so you can go and check that. If you're interested, you can look into the course curriculum and discuss further. That is up to you.
Yes, thank you all guys. Have a great day, and special
Thank you,
thanks
everyone.
to
Thank you.
Alok
Yeah.
for such a valuable insights. Thank you, Alok.